N or M, whatever you want to call it, it doesn't matter. What is the rule? I mean, we shouldn't, I mean, this should be very clear by now. We should use like 30 seconds for this.
You multiply the exponents. So x to the power of, again, whatever letter you had up there, times 1.
You're getting blurry now. I'm not sure.
Yeah. Yeah, it's difficult to read. But we're raising a power to a power, so we multiply the powers.
So what do I write?
X to the power of, I can't read the exponents, whatever the exponents are.
So it's x raised to power n, everything prime. This is the first rule we discussed. What do I write?
That would be mx.
N times x to which power?
N minus 1.
N minus 1.
Awesome. C prime. Great job. C prime.
E.
How much?
It's just 0.
Excellent. C times f prime. C times a function prime. So these are the basic differentiation rules. We can have difficulties with these. C times a function prime.
That's just C prime times F prime.
C is a constant. C is a factor.
Oh, it's just C times F prime.
Perfect.
Okay.
F plus G prime, or minus G.
That's just F prime plus or minus G prime.
Perfect. 1 over X prime.
-1 X, I don't know, the power 2.
So this is a very important rule, so please remember this rule. Very good. The square root of X prime.
1 over 2 times the square root of X.
Excellent. X prime. It's the slope of X. We should not even think of this. This should come in immediately, instantaneously to us.
1.
Perfect. E to the X prime.
E to the X.
Excellent. Very good. The notations for the derivative function. How many notations we know? Not definitions, just notation. When we talk about the derivative function, how do we denote it?
Isn't it delta dx?
So it's
Or
f prime of
dy.
x is the first definition. The first notation, f prime of x, or y prime, or dy over dx. I hope everyone will find the time to review the videos from last class. So these are the 3 notations that we will be using interchangeably in this class for f prime, y prime, or dy over dx. The product rule, f times g prime. Can anyone give us f times g prime?
That's F times G prime minus G prime minus.
Very good. You can twist them the way you like. I prefer 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. But you can twist them if you like. Okay, the quotient rule, f over g prime.
Is that?
It's the same
G
thing.
times, yeah,
It's the same thing with minus.
Over G squared.
Over G squared. Awesome. Good. So these are the rules. consider yourselves a little bit behind if you did not study these. I hope you're going to do that for Monday. There is no time to rest in this class. So sorry. Okay.
Could you put that back up for a second?
Sure. Everything here was copied from the previous lesson. Absolutely everything you see here was copied from the previous lesson.
Okay, thank you.
Thank you. So it will be posted again, of course, at the end of the class. Okay, any questions? Yes, I'm ready for your questions. Amanda, you're first. Anything you want. Anything that you need to look at. Anything. Are there questions?
Oh, sorry, I was muted.
That's okay.
I had a question on the homework. It's to differentiate y
Yes.
equals
Yes.
the square root of x times the quantity of x minus 8.
This.
Correct.
Okay, perfect. So we can use the product rule. So we have y prime. We differentiate the first function, 1 over 2, the square root of x, multiplied by the second function, plus the first function, multiplied by the second one prime, which is 1. We should find the least common denominator. We should multiply by 2 the square root of x, because this is over 1. I have in the numerator x minus 8, and then 2 the square root of x times the square root of x is 2x. So the final form should be 3x minus 8 over 2 the square root of x. What was the problem here so I can address it? That's how I learn from you. When you say, well, then I realize, well, maybe I didn't say something. So it helps me become a better professor. So what was the problem here?
I think what was I doing? I'm trying to find the notes. I tried it a few different times.
But is it clear now?
Yes.
Every step? Any questions, everyone?
So we differentiated the square root of x, but we kept x minus 8 together. I think that was my error, was I was trying to differentiate
A function times another function
minus.
prime
mhm.
is the first function prime times the second one plus the first one times the second one prime. First function prime times the second one plus the first function times the second one prime, which is 1.
Yes, that makes sense. Thank you.
Thank you. Other questions? Anyone? Did you work on anything else? Did anyone needs help with anything else? Okay, in that case, is it better now? Is it still blurry? Can you read what I'm writing or not?
No, it's better now.
Okay, awesome, great. Okay, we're moving on to derivatives of trig functions. 3.3, trig functions. Here we're going to look at those 6 trig functions. What are they? Sine, cosine, tangent, cotangent, secant, cosecant. Yes, we also have inverse trig functions. Later on, we're going to get to those. But for now, we're going to look at the trig functions and their derivatives. So sine prime equals cosine x. So maybe I should use a different color. Let me know if the colors I'm using are not visible or not clear. So this is negative sine x. This is secant squared. Cotangent is negative cosecant squared. Secant is secant times tangent. And cosecant is negative cosecant cotangent. Cotangent. So I would like us to apply them. We can prove any of these that you want. You can choose one and we can prove it. It will take a while. The process is a little bit cumbersome. If you would like to find sine or find cosine, Or if you want to find tangent, how do I find tangent? Well, I know the tangent is sine over cosine. Let's apply which rule applies here if I want to differentiate sine over cosine? Which rule applies?
The quotient.
Yes, of course. So can you tell me what I will get? Sine prime, which is cosine, times the denominator, minus the numerator, times the denominator prime. Of course, you know me, I always run out of room. Over the denominator squared. But the numerator is now cosine squared plus sine squared. Anyone remembers this super important trig identity? How much is this?
1.
Yes. So it's 1 over cosine squared, but by definition, 1 over cosine squared is secant squared. So we proved this one based on sine and cosine. And we can always prove
Can you
that.
go through that again for me, please? At the right corner, it's a bit blurry for me, so I'm not sure what you wrote there.
Negative sine times negative sine. So the top prime is cosine times the denominator minus the top times the denominator prime, which is negative sine, over the denominator squared. So cosine squared minus sine times negative sine will be positive sine squared. Is that better?
Just a little, I'm trying to see.
Negative sine x times negative sine x is positive sine squared x.
Okay, okay.
Is that better?
Yes, it's better.
Perfect. Okay. So I do have a little discussion that I prepared for you from 6:50 to 7 o'clock. So I think let's stop for a